we'll go, we will be looking at types of data, and then we'll have, this will last about 45 minutes, and then we'll have a quick sort of 5-10 minute break, and then we'll move on to a session led by Shifa. So yeah, today we're looking at different types of data. Oh, why is my thing not moving? There we go. So some key objectives for today's first session will be, sort of by the end of the session, you'll want to be able to describe and identify the differences between various types of data. And this includes sort of quantitative data, different types of quantitative data and qualitative data. And we'll also look a little bit about file types and understanding a little bit about some of their differences. The majority of this session does focus on sort of data that you find within data sets. So sort of numerical data, categorical data, those sorts of data things, that's mostly what I imagine people would be looking into. We will touch on qualitative data a little bit, but the majority of the data management for qualitative data will be part of the 4th module, which will, can't remember the exact dates off the top of my head, but that's a little ways away. So as I say, most commonly you're going to be working with data that is stored in some form of data set or a spreadsheet. You know, you've got your rows, and these are holding all of your observations, all your people, or your plots, or your plants. And then you have your columns, and these are holding your specific variables. They could be some sort of measurement, perhaps the height, or something to do with germination. You may have some other data sources if you're doing something a bit more than just this traditional quantitative data analysis that we're mostly familiar with. For instance, you might have photos or interview transcripts and recordings, and these are sort of leaning into the more qualitative data aspect, which we'll touch on a little bit today, but as I say, that will mostly be addressed in the 4th module, which Nuru will be leading. So let's start having a look at some different types of data that you can have within a data set. So these are different types of variables, essentially. The first one we're going to look at that is become increasingly important when it comes to this kind of era of data science and data engineering that we have these days is these identifier variables. So I'm just going to play a quick little thing from this video link.
The identifier data usually consists of several variables that are commonly concatenated and referred to as the unique identifier or primary key. Identifier variables can be numeric, text, or alphanumeric depending on the context. The identifier variables and primary key must uniquely identify each measurement unit in the activity, whether this is an individual or a plot. All datasets must have a variable or set of variables that uniquely identifies each record. The identifier variables relating to individuals or households must be anonymized. Numeric.
Okay, so as we saw there, these identifier variables, they are extremely important to data management because they allow you to uniquely identify every record within your data set. And these have become especially useful more recently when we kind of more commonly seem to be dealing with projects that have multiple data sources, or they use some form of repeated measures over time. So you need some way of linking these data sources together so you know you're dealing with the same person, the same plot, etc. So these identifier variables or keys are often how they're called when it comes to sort of the database and data science sort of way of looking at things. Now, how we can link these observations across our data sets and make sure that we are following the same person. In the video, they mentioned sort of concatenating, smushing together a few variables. I would say that this probably isn't the recommended way anymore. It's not something I've really tended to see. Usually it's some sort of ID number, which it could just be the row number of the data set is something you often see, or some sort of randomly generated string of letters and numbers. For those that have used Open Data Kit in the past, so using Kobo tools or ODK Collect, when collecting data through these mobile methods, they usually provide an ID number generated itself that will just, when you download the data from Kobo, that ID number is there. I believe it's, I can't remember the name of the, off the top of my head, but it provides this uniquely generated ID number for all of your records when you use that data collection system. Often when you have a data set, you'll find them as either the very first column or it's one of the very last. Again, with these ODK ones, they tend to put it towards the end, as in essence, they are sort of an extension about this sort of idea of metadata, data about data. For those sticking with us on our module on data management with R specifically, this will be a key idea, as during that module, there'll be quite a large focus on relational data, which is this idea of you have multiple data sets and they need to be linked in some way. So identifier variables and primary keys, these sort of things are going to be very important when it comes to handling that sort of data project. Moving on to numerical or continuous integer data. I think it's quite likely this would be probably the most common type of data that you're going to find in your data. So this is dealing with data that's, numbers, decimals, counts. Again, I'll just go back to the video.
Numerical continuous data is the result of questions or measurements that naturally give a number response, such as number of household members, yield measurement, plot size, age, amount of fertilizer applied, etc. Different types of numeric data will require slightly different formats to account for different levels of precision. For example, number of individuals or age should always be recorded as a whole number with no decimal places or fractions, whereas when measuring a response such as plot size, it is usually appropriate to include a number of decimal places. When numeric data are the result of measurements, the units should be specified in advance or be recorded in a separate text column if they are not consistent across all observations. For example, plot sizes in hectares, acres, and local units. Additional numerical fields can be derived as part of the transition from raw to primary data. Categorical.
So as I say, this will likely, these sorts of variables, when you're dealing with plot size or yields, these are probably forming a lot of your data when working with specifically data sets and statistical analysis or some sort of experiment. And these can take many forms, in that they could be measurements and counts. And as we say in the video, that quite a few types of questions such as household size and age, these will be what we call integers. So these will only take whole numbers, no decimal places. Things like yield or plot size may more likely be decimals. Again, you can decide when doing your survey or measurements what number of decimal places that needs to be. Similar to integers, we also have counts. So how many of a certain thing there are. This is, again, similar to integer, and they can only take a whole number, but it would have to be positive because you can't have minus of a object, essentially. So with qualitative data, there's a couple of different ways you can think about qualitative data. Either you could consider qualitative data in that it would include things like categorical data and free text data, where the question being asked is not looking for a number, it's looking for some form of text. So this could be, what is your sex, male, female, other, or a kind of free text field where you say there was already a multiple choice question and you've picked other, and then you are asked to write in specifically what you mean by other. And these sort of questions these sorts of bits of data can easily be found in a data set. It's quite common to find these in some form of just short survey. The other way to look at qualitative data is considering things like the results of in-depth interviews and focus groups or ethnographies or literature reviews, those sorts of things. So as I say, there's kind of two ways to look at qualitative data. When dealing specifically with data sets, we're referring to categorical data. So that's coming from questions such as what is your sex? Free text data, where you've got usually something like specify other, where you have no given response and you have to write down whatever it is. Also, you have multi-response data. So multi-response data is coming from multiple answer questions. So kind of a please select all that apply. So give the farmer a list of crops and they have to select all of the ones that they grow. It could be one, it could be none, but it could easily be 5 or 6 different types. And then to an extent, we also have binary data. So this is where there are only 2 possible options. Usually we're referring to sort of a yes or a no. Yes being generally equal to 1, no being equal to 0. So binary data, because we can treat it as a 1 and a 0, it's slightly special. It's also known in sort of data science terms as a Boolean data type. And as I say, it can be treated slightly specially, and there's a few sort of quantitative data analysis things you can use with it, such as when you have this binary variable of 0s or 1, if you actually take the mean of that, you will have the percentage that equal 1. So in a way, binary data can be treated both quantitatively and qualitatively. It's a sort of special case. And just to summarize, I'll show the video as well.
Data or factors are questionnaire or measurement responses that fall into categories. For example, respondent gender, male or female. Where categorical data is being stored numerically, each of the categories should be assigned a code, and an accompanying data dictionary must always be provided to decode the information. For example, 1 equals male and 2 equals female. Code lists from within a data dictionary can be recycled across questions if the same categories are used in more than one question. For example, using a single list of occupations, the primary and secondary occupations of an individual can be recorded. Free text data is text data that cannot be coded into categories, such as respondent name, or data resulting from an open-ended question, such as give your opinion, do you have any further comments, or enumerator comments. Free text should be entered exactly as seen in the original source. No text should be paraphrased, however punctuation and accents will need to be removed. If free text may need to be used for any analysis, for example, if the frequency of respondents mentioning a key phrase or word is of interest, it is useful for the data to have been entered either all in uppercase or all in lowercase. Multiple response data is usually the result of responses being a list. For example, name the main types of crops grown on your land, or what livestock do you keep, etc. The first option for storing this data is for the number of variables, or columns, being the maximum number of responses given by any individual. The first response given by a respondent is then entered into the first variable. the second response into the second variable, and so on. The second option is to create a variable for each unique response given and indicate whether each, say, crop, was specified by the respondent using a yes-no or coded 1-2 responses. This is usually preferred by the analyst. However, it can result in a large number of variables. Avoid.
So I saw those sort of two different options for actually dealing with this multi-response data. As a recommendation from myself, I certainly agree that the second option, where you have all of the possible options labeled for each column, and then kind of a yes, no, 1, 0, true, false, representing whether or not the respondent picked that option. For those of us familiar with quantitative data analysis, you'll find that this is a much easier way normally for analyzing that type of data, as it's much more cohesive. So moving on to missing data. So this is kind of a special form of data, again, you could say. It's not specific form of a whole variable, obviously, but it's a characteristic of sort of within a variable, certain observations might have some missing data. So for a given observation of a given variable, that data is not there for some reason. And there's many reasons why missing data can happen. You can have some sort of data collection error. Perhaps this question was skipped when it wasn't meant to be, or the respondent simply refused to answer. Again, sort of questions skip hands, but actually done correctly. So for whatever reason, that question is irrelevant to that participant, therefore there's no data for that question. Or there's some form of data entry error in some way. And there are many ways you can deal with missing data that will tend to be done normally as sort of a data cleaning stage or in the survey planning itself, such as, especially when it comes to survey planning, one of the big ways to do this is through missing codes already programmed into the survey, such as ones we see commonly in our work is putting, say, -9 for refuse to answer or -8 for a don't know. Another way that's quite common is just to simply leave that cell essentially blank or put in NA kind of thing. One I've forgot to mention on the slide there also is I think more commonly used later on when you're starting to look into the analysis of your data and you decide that you don't quite have enough observations for whatever analysis you're doing, if it's some sort of regression model, etc., is to use some sort of interpolation method on this missing data. So this could be setting that missing data to be equal to the general mean or the mean of the area where that specific observation comes from. So not all missing data is the same kind of thing. And there are many different ways of interpolating as well. It could be the mean, could be the mode. So some people use a bit more advanced, but going into regression methods, getting a predicted value for that variable based on other variables that they aren't missing. So just to have a look at the video as well.
Collecting missing data. For categorical variables, ensure the group responses cover all options. For example, when asking about highest level of education obtained, include a category for no education, so that these responses are not collected as missing. You can also add NA and other codes with space to add the details. When collecting numeric data, ensure the value for missing cannot be a plausible response. For example, use -99 or a number 10 times that which could be considered a response, such as 999. Try to use consistent missing codes. This will assist the enumerator and reduce the number of mistakes during data collection. The document that corresponds to this video includes additional advice on the types of data introduced in this video
So sort of moving slightly beyond the scope of the video, another key bit of data that thankfully isn't too commonly used in analysis specifically, unless you are intending to deal with some sort of time series analysis, maybe survival analysis, or dealing potentially with something that is repeated measures over time, some sort of longitudinal project. But dates and times, they can be quite a frustrating type of data to deal with, because often different sources will put them into different formats, different pieces of software will put them into different formats, and it can be quite frustrating swapping between them and getting your software correctly even recognizing it as a date. So with dates, it's best to get them formatted and sorted as early as possible in your sort of data management process. So dates, they need to be sort of unambiguous. So you need to be able to look at it and understand what it's saying, what date it means. The sort of general advice is to store in what's known as ISO format. So this is, as you'll see here, you have a year, and then dash, and then the month with 2 digits. So say if it's February, it'll be 02, March 03, and then the day of the month. Again, if it's a second or third, put 0. So for instance, today's date in that format would be sort of 2022-01-27. This is the sort of format generally preferred by sort of database software, and it's pretty much always readable by both machines, regardless of the software, and also it's generally pretty clear for people to understand what it's saying. With Microsoft Excel, which I know a lot of people here would use, the kind of default format is a little bit confusing sometimes. Often when switching between Excel and some sort of data analysis software, you find that the date ends up getting formatted as the number of days since the 31st of December 1899. So today is I don't know, so it's like in the you'll get the number like 47,000 or something like that, and that can be a bit confusing if you don't understand that that's what it's trying to say. It's difficult for us to read. A computer understands it, and again, in data analysis software, it's simple-ish to convert that number into the actual date as well. But as I say, generally 2022-01-27 is normally the best way for dealing with dates. So going on to outside of this and actually considering how your computer is reading this data in terms of the file type, very commonly you'll probably be using CSVs. So these are comma summated files. So you have all the cell values are separated usually by a comma. So this is common for Excel when working with data. There's in just the single spreadsheet, so you only have one sort of table of data. Essentially, that's all you have or all you need. And any software can use this. It's nowhere will ever have a problem with CSVs. It's quite robust. So if you are dealing with sort of single pieces, single data sets, this is probably the recommendable way to store that data. Similarly, with Microsoft Excel, you have XLS or XLSX, or I think there's another acronym as well. They're all quite similar. So these are similar to CSV, but whereas CSVs will only be that one table of data, XLS will have multiple sheets within that Excel workbook. So again, this should be a format that generally you're familiar with. So this is, you can consider this usually a simple alternative to storing data in some sort of relational database, where you have multiple data sources that can be linked, rather than store them in the database. If you aren't prepared to sort of go that extra length, you could just store each bit of data on a separate worksheet in an XLS file. Moving on to sort of ones with specific applications to data analysis software that I'm sure many of you will be familiar with. You have your SAV file. So this is the standard data format for SPSS. RDS is one way of dealing with data from R. It's not that commonly used, basically because R can just handle whatever format of data generally that you can throw at it. So R will take a CSV file, it will take an XLS file, it will take a SAV file, it will take a DTA file, which is the one that generally comes from Stata. It will take things from databases, a bit more complicated to set up, but it can do that. And speaking of databases, so these are generally very good for data management, obviously, but we understand that it can be more of a learning curve to get into that sort of level of data management, and it can be quite then also technical actually exporting that data to other software. So although databases are definitely probably the peak of data management, so we're talking about SQL, Azure, Access, those sort of things, we understand that that's a very technical advancement from what we're dealing with here, so we don't need to really dwell on that too much. Generally, I think everything that most people here will be doing, a CSV or an XLSS, that's probably all you need. And just to finish off, as we say with qualitative data, you have, you're dealing with quite different sort of forms of data, and you're not dealing with data sets, you might be dealing with images and text files. So just a little bit on those. So say with images, photos, etc. These are often sort of retained in their raw formats. So how they were developed is how they're sort of saved. Although depending on the size of an image, sort of like these standard data formats of a PNG or a JPEG, the sort of most common ways you're going to find an image file stored is that's the preferred data file type, essentially. With audio and video, you might have perhaps, again, you'll keep them as that raw format, how they were recorded. So you keep that original version. Perhaps when you archive or save this in somewhere, you may need to kind of compress them because audio and visual files usually come out with very large file sizes. So you might need to get slightly technical with it to reduce that kind of data storage burden, essentially. And because of developments in audio and video, there is a tendency for certain formats to have short lifespans in terms of recommendation. But for more information on these sorts of areas where we're dealing with things beyond data sets, such as text documents, or perhaps even if you're doing something with geospatial data, if you're doing some sort of spatial analysis, you might be doing some GIS work perhaps, and documentation and scripts to look at how it's best to store these and what formats to use for those. There is a link on the screen, and I believe should be on the site for a guide from the UK Data Service, and this sort of deals with recommendations for how to deal with all sorts of data that you could possibly think of. And then there's a few extra links there as well. We have, again, that UK Data Service source. There is the guide that the video was referring to at the end there. So again, elaborating on that video and also dealing with a few other areas that were not covered in this session. There's the link there for the video as well, and also an additional video here that Stats4SD did on importing data into RStudio. Don't need to watch all of this. I believe it's the first, I can't remember if it's the first half or the second half, but the video covers a little bit more material on the differences between CSV and XLS files and how to sort of save between them. I think that sort of brings the presentation part of this session to a close. I think we have sort of 10 minutes now before a break, if we want to discuss any questions. So if there's